Hi, and welcome to my video on word problems using logs, part 1. An ounce of gold depreciated 2.5% a month. Find the number of months if the price fell from 1800 to 1397. Okay, we have a 2.5% is the rate. C is 1. And the price, we have to find the number of months, so that's T is the number of months. And the initial price, which we'll call PO, is 1800. And the price that it fell to is P, which is 1397. So the formula is P equals PO, PO standing for initial price, and it depreciated, so it's 1 minus the rate, and it's T over C. C is the increment change, T is the time. So we have 1800, it's going to 1397, and it's 1 minus the rate, which is 2.5. That's 2.5%. The time is what we have to find, and it's each month, so it's a 1. So let's take the percent, leave this alone, and the percent is 2.5 first. That's a T. So let's take 1, subtract 2.5% and change it, so it's 1. Percent is 0 decimal. Move your decimal place 2 places to the left, 0 to 5. So 1 subtract that is 0.975. Okay, let's put that back in our problem. Rather than keep writing down the problem all the time, just work that out on the side, just quicker to write down. Now we have to isolate the exponential, so we divide by 1800 on each side. So we get decimal 975 to the T power, and 1800, we could change it, take your calculator and divide that out, and you get 0.776 to the nearest thousand. And now this changes around because I like to have it in 0.975 to the T is 0.776. So we do, because T is in the exponent, we'll do the log of each side. And that's done. And we bring the T to the front because of the power rule. I do not, after I move the T, I don't need that decimal there. And so now we divide by the log of 0.975 on each side. Cancels out, so T is equal to, and you take your calculator and work this out. And when you take the log of decimal 776 and divide it by the log of decimal 975, you get a 10. And it comes, I made it up, I made these numbers up, so this would be no confusion. This would come out. So the answer, it takes 10 months for $1,800 in gold to go to 1397 at 2.5% a month, and it's exponential. Let's do another one. The price of a ticket increased by 6% per year. To the nearest year, how long will it take to triple? Well, we have prices increasing, so we have an increase, so the base is going to be the base. Oh, let me do this. The base is 1 plus the rate, because it's an increase, and your rate is 6.3%. And it says how long will it take it to double. So we have PO, the price is PO, and what happens is that the price of the ticket, no matter what this price is, it's going to triple, so it's 3 times. So the formula is P equals PO, and the rate is 1 plus R, and it's again T over C. So PO, the new price is triple. We don't need the price. Again, if this was 1,000, this would be 3,000. If this was 2,000, this would be 6,000. So when you divide, you'll get a 3. And the rate is 6.3%. And we're looking for the time. Time is what we don't have. We're looking for how many years. And C is 1. So we divide by PO on each side. So we get 3 equals, and these cancel out. And let's work out 1 plus 6.3%. So 1 plus 6%, 6.3%, move decimal 2 places to the left. And that gives us 1.063. 1.063 to the T power. And again, I like to have it with my exponential on the left and my number on the right. So I'll do the log of each side. And the power goes in front, T, power rule. And so we divide each side by the log of 1.063. Cancels, so T is, you take your calculator and the log of 3 divided by the log of 1.063, and again I made it up to come out to be 18, and you have no confusion. And I'll just work this one out for you. Okay, just to make sure you know what you're doing. And again, we have the log of 3, and we divide by the log of 1.063. And it comes out to 17.98, and that's close to 18. Hopefully you can visualize or understand everything that's happening. So we have another problem. When a certain drug enters the bloodstream, it gradually dilutes, decreasing exponentially with a half-life of 4 days. How many days will 20 milliliters become 2.1 milliliters? So what we have again a decrease, but it's a half-life this time. It's an exponential, so the half-life is H, half-life is 4 days, and a half-life means the base is a half. So we have an equation that we got the bloodstream. So what I'm going to do this time is do AO is what's put in your bloodstream initially, and A is what comes out. And the base is, let me put the base in, let me put a B here, and it's raised to the T over H. So we have the base and time, and H is for half-life. So what we have, if we want to find out, it's going to be a half-life So we have, oh, I didn't put the amounts in. So the initial amount, which was AO, is 20, and A is 2.1. So 2.1, and the initial is 20, and the base is a half-life, half, and we want to find the time, and the half-life is 4 days. Now, to solve this, let's divide by 20. We want to isolate the exponential. So this is 1/2 t over 4, and this is 20. 2.1 divided by 20 is 0.105 if you use your calculator. And again, I like to have just something about it. You don't have to, but I like to have it as the exponential is on the, with the power is on the left, and we do the log of each side. And the power or exponent goes in front of the log. And now I want to solve for t, so I'll divide by log of half on each side. It cancels, so I get t over 4 equals log 0.105. This is the log of a half. And we want to solve for t, so t is equal to, so you multiply 4 times log 0.105 and divide it by the log of a half. So again, you cross multiply and then divide by log of a half. So t, so if you take 4 times the log of 0.105 and divide it by the log of a half or log of 0.5, it comes out to be 13. So it's 13 days. And again, I'll show you that division. So we got 4 times log of 0.105, and we divide it by the log of a half, and the half is 0.5, and I'll get 13.006. So you can see it's very close to 13. And again, I made the problems out not to be anything of a hassle. And we have one more to do. Number 4. The population of a city increases by 3% a year. Find the number of years when the population will be increased by 80%. So the rate of increase is 3%. C is 1. So, and find the number of years, so we have to find the time when the population will be increased by 180. So increased by 180, so if it's going to increase by 80%, that's 80% added on to what you already have. So that makes it 180% altogether, because it's 1 plus your rate, so it's 1 plus 80%. So it's, as you can see, 1 is 100% plus 80%, so there's where the 180 comes into. So it's 180%. So what we have is that we have a P and a PO. So that means you take the PO and you take 180% of it. So the initial amount is PO. So what we have is 180% of PO. The initial amount of population is PO. And the rate of increase is 1 plus the rate. And we want to find the time and C is 1, so it's T over 1. So we have 180% PO, this is PO, and this 1 plus the rate, so it's 1 plus 3% raised to the T power, and 1 plus 3%. 3% is 0.03. The decimal in the 3 is to the right, so you move it 2 places to the left, so that's 1.03 when you add up. So we have 180% of the original population. This is the original population, so this is 1.03 to the T power. We divide by PO, so we get 180%, and divide, we get 1.03 to the T, and 180% is 1.8, 1.03 T, and so we have 1.03 T equals 1.8, and again, we need to do a log because we have to get at the exponent, which is up in the power. So the log of 1.03 T equals the log of 1.8. So T log 1.03. The power moves in front. And we have to divide by the log of 1.03 on each side. So T is equal to, so you take your calculator and you go the log of 1.8 divided by the log of 1.03, and it comes out to be 20. And again, I'll show you that manipulation or that working there. Put my pen down. So I get the log of 1.8 division log 1.03. And 19.885, and it says 19.885, it will be increased roughly. You take, that's 20 years for the population to be increased that much. Again, notice we have a PO, and this is 180%, so whatever this population is, 180% of it. So if you take a population of, say, 2,000 people, and you increase it, you multiply it by 180%, that's 100%. So that's 1.8 times it. So you'll get 3,600. So notice it's just not 80%. The 100% is the 2,000. So it's a 2,000 plus 1,800. So there's the 100%. And this is 80%. Because 80% of 2 is 80%. 3,600. Oh, that's a 6, which is 1,600. So 80%. And 100% gives you the 3,600. So again, I just doing a little bit of explanation here, making sure you understand why I put the 180 here. And just thinking to myself then, think not out loud, that's the end of the problems on this video. And again, if you like my video, click on the like button, click on the subscribe button if you're not a subscriber, and visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.